Alright, and we're here today to solve systems of equations, where we are given two equations, and we are asked to find the coordinate at which they intersect, or the coordinate they have in common. So I have a couple of examples on the screen here, and we're going to solve these by graphing the system. So we have number 2 right here, where we're given two equations. The first equation is y equals x plus 1, and our second equation is y equals negative 2x plus 4, and we're going to solve this system by graphing. And what solving means is finding the x and the y value that works in both of the equations, not just one of them, because there's a ton that we can find that satisfy this equation and a ton that we can satisfy this equation here, but there's only one, at least we hope there's only one, that satisfies both of them at the same time. So what I'm going to do is take this top equation, y equals x plus 1, and I'm going to graph it. When I look at this equation that's in the blue, I notice that it is in slope-intercept form. So what I am going to do is identify the y-intercept. The y-intercept of this equation is 1. So I'm going to plot the point 1 on the graph right here, because that is the y-intercept of this top equation. The slope of this equation is also 1, because the slope is the coefficient, or the number that's in front of the variable x. There's no number here, so if there's no number here, the number that is actually there is 1. So our rise over run in this case is up 1 over 1. Up 1 over 1. And we can find several different points. Another one right there. If we draw the line that connects these 2 points, this is the line we get. So this blue line right here is the line for the equation y equals x plus 1. Any of these points will satisfy this equation. Now we're going to graph the second equation, y equals negative 2x plus 4. This equation is also in slope-intercept form. I'm going to identify the y-intercept, which is 4, so I will plot that point right here. And the slope is negative 2. Negative 2 over 1 if we were to write that as a fraction. So from our y-intercept, we use the slope by going down 2 over 1, and we find another point that is on the line, and then we can draw the line that goes through those 2 points. So the red line is the line for the equation y equals negative 2x plus 4. The solution is where the 2 lines intersect, and the 2 lines intersect at this point right here. So therefore our solution to this system is 1, 2, because the coordinates for this point are 1, 2. So it says give the solution. Our solution is 1, 2. And then we can check that solution in part C here by saying if x is 1, then y is 2. If we plug that into the top equation, y equals x plus 1, we get 2 equals 1 plus 1, which is true. So it does indeed satisfy the top equation. We'll check it for the bottom equation, y equals negative 2x plus 4. If we plug that in, we get 2 equals negative 2 times 1 plus 4. Negative 2 times 1 is negative 2. Negative 2 plus 4 is positive 2. So that coordinate also works for the bottom equation as well. So therefore the solution to this system is 1, 2, because 1, 2 satisfies both of those equations. Second one here, we have 2 more equations. The first equation is y equals negative 3x plus 4. The next equation is 6x plus 2y equals 12. And we're going to solve this by graphing. We'll take the blue equation first, identifying that this is in slope-intercept form, where our y-intercept is 4 and our slope is negative 3. Negative 3 over 1 if we write that as a fraction. So we go down 3, right 1, and when we have another point that's on the line, we can draw the line that goes through those 2 points, and there's the line for the equation y equals negative 3x plus 4. The bottom equation, the pink one, or the red one, is not in slope-intercept form. It is in standard form. So writing or drawing a line for this is going to be a little bit different than drawing the line as if it's in slope-intercept form. If it's in standard form, we're going to identify the x and y intercepts. So identifying the x and the y-intercepts, our x-intercept is when y is 0. So if we just kind of eliminate this thing, because 2 times 0 is 0, What does x have to be so that 6x is equal to 12? Well, 6 has to be, or x has to be 2. So our x-intercept is 2. Our y-intercept is going to be when x is 0. So we plug in 0 for x, making this go away because x is 0. So 2 times what gives us 12? That's going to be 6. So our y-intercept is 6 and our x-intercept is 2. Here's our x-intercept of 2. Our y-intercept is 6, which is right there. If we draw the line that goes through those 2 points, this is the line right here for the equation 6x plus 2y equals 12. And the solution is where they intersect. Where do these two lines intersect? They don't. So since they don't intersect, what that means is that there is no solution to this system of equations because the lines don't intersect, and if they don't intersect, they are called parallel. So there's no answer whatsoever to this system of equations because when we graphed the lines, they did not intersect.